Hey, what's up, everybody? It's Chris. Hey, wait, where's our names? How come our names aren't showing up? Oh, well.
Oh,
It's Chris and Dan.
hey
Dan,
guys.
Dan from Slice. He's over there. So, yeah, it's Sunday. We're here before football, so everyone can be ready for football. Well, for the Americans and some of the
Right.
Europeans that watch football. You have a new product.
Yes,
You guys are
we're pretty
famous for the
excited about it.
mosquito. I used to
Yeah,
have one on my desk, but now I. Oh, wait.
it should be
Nope.
on one of your printers, right? At least
Well,
you got a Magnum on one of your
yeah, the
printers.
Magnum's on that one. And somewhere in my box of testing stuff, apparently I put my mosquitoes. I used to have two of
Gotcha.
them in that drawer, so I can just grab
Oh.
them when I needed them. I don't know where the dirty one went because I had one that I exploded. Stupid nozzle that I got from Germany was, instead of being 7 something millimeters, it was like 6.6 millimeters in the thread length.
Okay,
And it just,
gotcha.
yeah. I didn't realize
Right,
it had hit the heat break before it did any sealing, and
right.
I made a mess.
Oh man, that is a mess. We've done that a couple times with, we try to test a bunch of different people's nozzles,
Yeah.
and yeah, we've done that too. Where if there's a significant difference, you can in length, you can tell.
Yeah.
But if there's not, then sometimes you just end up making a big mess. So
Yeah. It was that nozzle for, I can't remember the company that made it. I think I have the box in here somewhere, but it's the one that says it's supposedly just the nozzle doubles your extrusion speed because it has 2 ports. So
okay,
it's
yeah,
a,
like the mixing nozzle.
well, it's not
Well, it's
really
not a
mixed.
mixing one, but yeah, I know what you're talking about.
Yeah, it's dual ported, so you can do
Yeah,
double the amount of material at one time, and then it still goes to the same point. It makes sense. You're
right.
melting twice as much material, so.
Yeah,
But I can't test it on anything because if I even put on an E3D V6, the heat break, I mean, the offset's ridiculous. I mean,
right.
all right, we're getting off topic. We're here to talk about the Slice Engineering product. So there's our website below, but we're talking specifically about the Copperhead, which the Kickstarter is below, and it's successful. I just checked this morning, and you guys broke
Yeah,
your $30,000 thing that you needed
yeah.
to make the
Target,
thing and stuff.
Target.
Yeah, the target.
Yeah, I'm
uh,
pretty excited about that. I was a little worried there for a few days that we weren't going to, but we sort of took off like a rocket the last few days.
yeah, I
So.
mean, it was like 7 grand 3 days ago that you needed. Then all of a
Hmm.
sudden it was 3 grand. Then I wake up this morning and it's like, well, I joined Mr. Buttram, who's down there. I joined his live stream yesterday, and you guys were at like 2 grand. And I was like, wow,
Hmm.
it's gonna do it.
Hmm.
Or maybe during the live stream today, he'll do it. And I was like, damn,
Already done.
it already done. So congratulations.
Thank you.
What
Thank you.
I guess the first thing that I want to ask was the hardest question of them all. Everyone's want to know,
Mhm.
what's with the love of oranges?
What's with the love of oranges? So it's sort of a Florida thing. We're a
Yeah.
Florida-based company, and there are orange groves everywhere.
Oh yeah.
At least where, honestly, not so much where we live now, but like when I was in high school in Florida, I ran cross country and track, and we would go. There was all these orange groves everywhere,
Yeah.
and so you'd go run through the orange groves during practice to get your distance in because they were everywhere. And so sometimes, when the coach wasn't around, we'd have fights in the orange grove. Which, if you've never been pelted with an orange from a guy who throws a baseball, and it
No.
leaves a huge welt. Um, but it's a ton of fun. So
Florida
oranges
man.
are just yeah, oranges are just sort of part of the thing. So that's where they came from.
3D printing Belgian was just like Florida man caught with House of Oranges.
Exactly.
But okay, so you guys make hot ends. You started with the mosquito,
Hmm.
and from the mosquito, you were like, "Hey, there's not really good thermistor," so you made a better thermistor, and you're like, "Why
Yeah.
don't we make a better heater cartridge?" Which I have on 2 printers right now.
Uh-huh.
Um,
The thermistor or the heater or both?
I don't actually have the thermistor on any printer. I
Okay,
have the
gotcha.
thermistor; it's in my drawer
Uh-huh.
of thermistors.
Okay. Yeah.
But it needs a custom temp table. And
Right.
then the community for Prusa, actually, one of the guys, Josh, who's in charge of making all these profiles for all these different printers. If you want a taller Prusa or a BMG Prusa or a Mosquito
Hmm.
Magnum Prusa, he's got all the profiles, and they auto make. So when Prusa releases their update, it auto makes with the things needed to the. It's
Oh,
pretty
that's
awesome.
fantastic. That's
But he
really
actually
great.
made them for the Slice thermistor as well, and I'm just
Very
been
cool.
lazy because
Okay.
so many things to test. But yeah, you guys made those things, and then you made a nozzle.
Yeah.
which is on three of my printers right now, actually.
Okay. Very
So
cool.
just one of those printers is at someone's house. They're borrowing
Oh.
that printer, Dan. But
Not the same.
yeah, so you've got a product lineup, and
Yeah.
how is the how's the response been to those products so far?
Really good. Yeah. So I'm an engineer. Is my background. Chris, my co-founder, not you, Chris, the other Chris.
I
There's
did
a lot
go to
of
school
Chris's
for
in 3D
engineering.
printing. Hey, there
Yeah.
you go. Yeah. So we're both mechanical engineers by education, and then did that for our careers for a while before deciding to do this. And so earlier this year, Chris went full time in January with Slice, and then I went full time with Slice in July. So so the products are doing well.
Awesome.
We're selling them. I'm paying my mortgage with with my paycheck from Slice, so that's a good thing. It's a dream come true. Yeah, so it's doing really well. We're expanding the offerings for Mosquito as well, and we're also, of course, diving into this Copperhead side of things too. So
yeah, which is on this printer, and I printed my first thing with it. I finally,
oh sweet,
yeah, I ran like 1 million tests on just a stock Prusa. Like I rebuilt this thing to stock using carbon fiber PTG that I printed with the vanadium nozzle. But
awesome.
Sales pitch. I print a ton of carbon. There's a stack of spools growing of all the carbon fiber printed. I'm at 40 rolls.
40 rolls. That's 40
kilograms of CF I've printed this year, just in 2019.
Awesome.
And I didn't start until your nozzle came out. So whenever that was.
Yeah, like March time frame.
Yeah. So next year might be 60 rolls. Who knows?
All right.
Yeah. So I ran it stock, ran a bunch of stuff, and I ran the exact same G code. Like this was calibrated. So this is the one from your Copperhead. This is the one from an E3D V6 stock. Same G code. So the retractions were the same. It looks like has a more E3D 0.8 millimeter type of retraction that seemed to work great. With the Mosquito, I'm used to having that. Basically whatever the nozzle diameter is, that's kind of where you start your retractions. And what's funny is I took a photo. I didn't put it on my computer yet. Because this is a PC, my Mac stuff, I don't know how to send stuff to this thing yet.
Right.
But there is actually physical improvement in the print. I mean, it's minor.
That's great.
But I wasn't expecting, because normally when I test hot ends and stuff, everyone's has a hot end. Like there's the J head and the Dies design has theirs. You have the Mosquito, now the Copperhead and the V6, and now there's the Dragon. There's all these hot ends, and they all have claims. So your guys' claim was heat creep. You didn't shoot for the this print's better. You didn't go for the typical marketing thing like you will just get better prints, which it's really hard to make a hot end that makes better prints. Like if people don't understand the science of printing, every hot end works. It just does it work optimally. Sure. Some hot ends have more heat creep than others. So I did a bunch of temp tests, and all the hot ends are thermally capable, unless you throw the wrong fan on it, which that seems to be the issue. If you don't cool it correctly, you have an issue. But your Copperhead actually ended up tying, technically in a sense, your Mosquito. So you did the due diligence, and the print quality was a little bit better. So I'll have some pictures up of showing just the minor layer. The layers came down a little bit better, and you can tell actually physically, which is awesome. So
yeah, that is awesome.
I do appreciate that you guys didn't go for the we make it print better everything. Your prints will be 100 times better campaign.
Yeah, we try to make claims that we can actually back up,
Yeah. And it did. So I ran the thermal tests, and let me pull up the number. Oh, I have it on my phone. So with the same hot end, so Prusa, I ran it two different ways. I ran with two different fans, because Prusa has the Noctua fan, which has been kind of everyone kind of goes to Noctua because it's quiet. You've got friends in the room.
Yeah, we have friends in the room momentarily.
Oh,
I'm posting up in somebody else's room. I don't even know whose room it is. So
it's not my room.
Yeah.
So I did a bunch of tests. I mean, I got my head hurts. I'll see all iCloud hot end tests. There it is. So I ran the test with a stock because you guys Max made this little rig that is a stock Prusa R5 extruder. So the fan distance is the same as it would be for a V6 or any other hot end that I tested. Ran it with the Noctua, ran it with the better Sanan fan, which is what's attached here. It's a little bit more powerful because that's the one thing people aren't taking into consideration when they make their printer. They'll buy all these mods. And they're like, Noctua was awesome. Well, they're actually horrible cooling fans, but they're quiet.
Very quiet. Very quiet. Yeah.
But on a computer, they're amazing because they have these giant, amazing heat sinks. So you don't have a giant, amazing airfoil heat sink with copper tubings and all that stuff to pull heat away. You just have fins. So there's only so much you can do with the heat sink. So when we did the testing, and I ran, this is how insane it was. Just to not cheat, I didn't just hook it up once, measure the distance where the bottom of the heatsink was, set my thermocouple, and then just heat it up. I did that once and then did the next hot end and then did the next hot end. And then I redid it from starting from step one, from the first hot end and going back. So every single time was a remeasure and a redo. And it was annoying. I mean,
I bet.
Because I didn't want to cheat. I didn't want to be like, well, I'm off by a millimeter on this test and just do 5 tests and then they look great. So I wanted to make sure that they were correct. And the Copperhead, so just to give you a specific, the V6 stock, so a aluminum heat sink with a stainless steel heat break with an aluminum block and a brass nozzle, all from E3D, with a Noctua fan, averaged about 48 degrees Celsius, which, again, this isn't the E3. This is not the E3D V6 being a poor hot end. It's the Noctua fan being underpowered.
Sure.
And if you don't know, a lot of people have clogging with Prusa, and a lot of people have clogging in general with an E3 V6. And it's not because of the V6, it's because cooling is important and the designs. I don't think the designs that people do for hot ends and extruders, they don't take into consideration the airflow. They just slap a fan on and they're like, this should work. Well, it could work. And then this is where it doesn't, because PLA, like I think you posted that in your Kickstarter, was if you don't cool the material correctly, especially PLA, because of its low distortion temp, will become a wet noodle in the hot end. So it ends up bending and twisting and smushing, and then you get a clog because you get this bulbous, thing in the middle of the heat break, and it can't do anything because it jams up.
The extruder is designed, of course, to pull on something solid, not on
a noodle.
A noodle, right? Yeah. Al dente.
Yeah, unless it's flex, then it's a noodle regardless. But then you definitely want good, better cooling, because
yes, absolutely,
that turns just into mush. So yeah, 48C was the stock with the if you had just a Prusa Mark III S stock out of the shop, $850 printer, you're not gonna just automatically get clogs. I'm not trying to scare people. You're not gonna get clogs automatically. But let's say you have a heat chamber or an enclosure, or you're middle of summer and you don't cool your house, you could get a clog because every time the room gets warmer, your heat break gets warmer. So, but then when I tested the Copperhead with the same setup, it was a 10 degree Celsius drop. So you went from 48 to 38, that's a ridiculous amount of change with a very underpowered cooler.
Right.
And it was even better when you put the better fan on. It went down to 35C. So we're talking a 15 degree Celsius spread from the least efficient setup to the most efficient setup. And that's a huge, I wasn't expecting 15 degrees Celsius difference. We've had community members who have tested the hot ends, and they're like, and my numbers were within range with theirs. And, we've never tested other hot ends. We just tested, here's the Prusa with this fan, and there's another guy coming out with a new fan for Prusas that drops another 3 degrees.
Cool.
All 3D makers going to make. So again, we're fighting this thing, but 15 degrees.
Yeah, 15 degrees is significant.
Yeah, and it almost matched the Mosquito. And again, I think I have an issue with the Mosquito. I don't know where exactly that transition zone is. I'm measuring everything from where the bottom of the heat sink is, just to keep it. It should be cold by the time it reaches the actual fins of the heat sink. Is the logic of a hot end? It should be firm because that's where it should be firm at. So. It's crazy. And this is all due to the bimetallic stuff, right?
Right. Yes. Yeah. So the science behind the bimetallic heat break is pretty cool. I don't know if you guys on the stream, if you haven't had an opportunity to take a look at the Kickstarter, Even if you don't back us, that's fine. But take a look at the graphic we have on there on the Kickstarter that shows the bimetallic heat break, and then Chris, my co-founder, posted a great update that sort of talked about why the bimetallic heat break makes sense. But basically, using there's a reason that people use composites all over the industry, every industry, right? Aerospace, medical, like people use composites because you can take advantage of the dissimilar characteristics of two different materials when you put them together. So that's essentially what we're doing with the bimetallic heat break. We're using bimetallic, right? Two metals. So we're using two metals with dissimilar characteristics, material properties that allows us to optimize for those particular properties in each part of the heat break. So we're using copper in the bottom section and copper in the top section, and then in the middle we're using a stainless tube. And that tube we have done a bunch of strain hardening on. It's all right, that's fine. A bunch of strain hardening on so that you get that higher strength, and we're able to reduce the wall thickness. So of course, conduction is a function of cross-sectional area that's in contact, right? So reducing that wall thickness allows you to reduce the amount of conduction that's happening axially along the filament path. And then additionally, having the copper sort of bonded to the around the stainless tube forces more heat flow radially. So by forcing heat flow radially, both in the bottom to get better distribution across the hot block, and in the top to get better distribution to the heat sink, and then not allowing heat flow axially along the filament path because of that lower conductivity material in the stainless, you really get, as you've seen, a massive difference in heat creep. It's really a crazy difference, 15 degrees Celsius.
Yeah, so basically for the layman's, the hot end stays hotter because the copper conducts heat better and actually has more thermal capacity than pure stainless.
Mm-hmm.
And then at the cold end, the copper absorbs more of the heat, releasing it better to the heat sink.
Right.
So that's why it works so well. So, and I don't think it's ever been done. I kind of looked at hot ends. I don't see anyone else doing two materials.
Right.
So this is completely new, and it's also open source. You've open sourced this whole project.
We have.
Which is ridiculous. So we might see, some copycats, but
sure,
I think in the long run, you've covered all the bases because your Kickstarter didn't just have one hot end. That was the unique aspect of this, this entire, experience that you built for everyone was you can just buy a heat sink and heat block, and it goes into or heat break and heat block, and it just goes into your existing hot end.
Sure.
So you just keep the heat sink, and something like a raised printer where that heat sink is kind of the entire extruder, same thing like the Hemera. I mean, the heat sink and the heat break, or the heat sink and the extruder are all one piece. The break and the block are the only things you can technically change. I don't think you want to be making heat sinks for a new redesigned heat sink for every hot end.
Definitely not. Yeah, we'd end up with so many heat sinks. Yeah, it would be crazy.
That would be, and you're just making heat breaks, which again, I mean, there's other companies that make really nice heat breaks. P3D in America makes coated heat breaks. They're still stainless steel, nothing crazy. Someone asked me to test the Micro Swiss heat break, again stainless steel but coated. But there isn't, and then there's titanium. So you've got your three, and it's plain stainless. So you got your four, basically stainless and titanium. Those are your two options in the heat break market. And you definitely don't want copper. You definitely don't want these other things. And then you used a special steel for the actual steel part of your heat break. What was that? I didn't look into it because I'm not a material science guy.
Sure. So it's a stainless alloy that basically it goes through a strain hardening process called cold working specifically. So cold work is just basically means you're smashing the stainless after it's gone through a treatment process. And this isn't just for stainless. Cold working can be done for any metal. But basically what that does is you are actually changing the alignment of the molecular structure so that the strains inside the grains inside of the steel are more in line. And what that allows you to do is increase the strength. So you're changing those material properties without changing the alloy itself. So
Okay.
it's more of a processing component, and this is done, on a wide variety of different types of metals. There's a lot of applications where strain hardening of various kinds occurs.
Yeah, and does this make it stronger or just?
It makes it stronger. Yeah, so it
Okay.
makes it stronger. So that's why we can have such a thin, because if you there's a trade-off between, ideally you'd have a super thin heat break that was also super strong.
Yeah.
But if you make your heat break too thin, you're just going to snap it off every time you try to change your nozzle. Right?
Basically.
Which happens. People do that.
Yeah, I just helped someone the other day who showed me a picture of his hot, and I was like, "It's bent." He goes, "Oh my gosh, I didn't know." And it's a full V6. Those are pretty strong, but you don't tighten that nozzle right, you will bend that heat break.
You will bend it. Yep.
Even my titanium ones, I've bent. It's
sure. Because it's a very thin piece of metal.
Yep.
So, we've tried to sort of strike the optimal balance between strength by doing this extra step of cold work and having the thinnest possible wall thickness. So I don't know if you again take a look at that update that my co-founder Chris posted on Kickstarter. He's got a couple pictures of different thicknesses of heat breaks.
Yeah.
And so you can see Mosquito's heat break is super, super thin.
Yep.
But that's because it's not a structural element. It's not.
Yeah.
It is not supporting the heat sink. Whereas Copperhead is more of a traditional design in the sense that the only thing connecting the hot zone to the cold zone is that heat break.
Yeah.
So can't go quite as thin, but it's still very, very thin comparatively speaking to what else is out there.
Yeah, I mean, and I got backgrounds. Sorry, I'm messing around back here.
Hey, that's
should have put the Copperhead back here. No, yeah. So I mean, again, the heat break has always been kind of like the fragile part, and I've at least mangled a few heat breaks in my lifetime, and supposedly I know what I'm talking about. But again, it's one of those things where it's like, do as I say, don't do as I do. We all break stuff, and it's good that you guys are going at least a step further to make sure that, hey, this is still thin, but we'll make it a little bit stronger. Hopefully no one breaks it, because it's not a cheap thing. I mean, it's not just a piece of polished stainless with some threads on it. Yeah. So you don't want people snapping those. Yeah.
Right. So there's a person, instead of, your standard heat break is just one solid component that's milled or put on a lathe more than likely. Yeah. Right. And it's cut all at the same time in one step. We're not doing that. We have an assembly, so it has to be put together by a human, and that's a little more expensive to do, especially the way we do things in America. All of our manufacturing is done, all of our machining and assembly is done here in the States. So we, it costs us a little more to do that.
Sadly, but hey,
but is what it is.
I think better in the long run, because again, I don't think anyone's had. I think in my entire lifetime, I found one person with a Mosquito that had a defect, and that was pretty crazy. I've seen I mean, I have a box of E3D products, and some copper blocks just won't accept a nozzle because the threading was done wrong. I mean, it just happens, but it's happened more consistently for me. But in the entire grand scheme of being on the internet and going to all kinds of forums, I've seen one Mosquito with a defect coming from shipping, and you guys replaced it because I think the tube was just a little like bent at the top, and it couldn't accept filament correctly. And a week later, he got a new hot end, and I was like, and this is why you buy these nice American products. They're typically built really, really well, and so when you combine the stainless or the work hardened tube to the copper, is that going to be friction welded or chemical welded, or is it press fit?
It's pressed on there basically. With you heat up you're going to heat up the copper to basically expand it, and then put it onto the tube and cool it down to rapidly cool it, right, to make it shrink down onto the tube. So it's not going to come apart very easily.
That's going to get hot because copper doesn't like to expand. Yeah.
It's going to get hot.
You guys are guaranteeing this thing to print up to 450 degrees C. So I'm guessing you're heating that block up higher than that just to fit it together.
Yep.
Oh
Yeah.
man, that's
It
gonna be
gets
fun.
hot.
You guys gotta do a video of that. Just a cool video of like this molten, almost near molten copper, and then the two
Right.
going together and then being cooled.
Yeah.
And that'll be like your
That'd
intro to the
actually
Copperhead.
fun. Yeah. That
So
would be a
that's
fun.
next.
Right.
And okay, so what else do you want to, what other info do you want to give us about the Copperhead itself?
Sure.
Uh,
So, as you mentioned, there's a bunch of different variants on the
yeah.
Kickstarter, which I think is kind of a unique aspect
Yes,
as
and you kept
well.
adding more. So I
Right.
just
We
looked
did.
today. I
Yeah.
was like,
So yeah, we've got we're launching with basically 5/6. I'll call it like 5.5 variants, because one of the variants is basically fits our heatsink natively, the Copperhead
yeah,
heatsink, which has a few cool features like adjustable Z height. We're using a shaft collar to
yep,
mate the heat break to the heatsink instead of using threads.
yeah,
So
that was
that
pretty
gives
neat.
you a little bit of Z height adjustability. And then the heatsink is actually, we designed it to not require a fan shroud. So you're mounting the fan directly onto the heatsink, but the way the heatsink fins are designed, and there's like an offset, and there's a bunch of little features that I went into making sure that you're not generating a bunch of noise
Yeah,
when the fan is running. So it's optimized to be quieter when you've got a fan or just airflow going across the fins. So yeah, and there's some cool mounting features.
yep,
There's a spot for attaching a cable, a zip tie to provide strain relief for your cables coming off of your fan and your heater and your thermistor. So there's a bunch of fun little features that come with the heatsink. And then the shank of that heat break that mounts into our heatsink also fits one of the raised printers and a couple others. And then we have a whole bunch of different varieties of heat breaks that are basically the same on the hot side, but are different on the cold side so that
yep.
they can fit a bunch of different things. So your Wellsbot Taz printers, your Race 3D printers, your Maker Gears, Wanhaus. There's a bunch of different printers that it'll fit. And as you mentioned earlier, there's so many different heatsink designs
Yeah, yeah.
that it would have been insane to try and build out an entire line of Copperheads that would fit
Yeah, a
everything.
bunch of optimized hot heat sinks. Because I
Right,
did notice the fins are a
exactly.
little bit wider. You guys have less air disturbance.
Hmm.
That's one of the things, when I'm an engineer by, college, and I spent a lot of time geeking out with a bunch of smarter engineers. So some of the things I picked up was, you guys have a little bit more gap space, kind of like the Mosquito. You have very little turbulence in the Mosquito,
Sure.
which allows for really good cooling, even with a really crappy fan.
Hmm.
And I saw the same things in this one where you compare like the J head or the V6, and you see the very tight spacing, which allows for more fins, which supposedly would cool more. But if you don't have enough
Right.
static pressure to push through those fins, you just cause turbulence, and you end
Right.
up with and that's why the Noctua is so poor at cooling a V6, is it can't push air through all those tiny fins
Hmm.
efficiently enough. And these
Yeah.
wider fins will help with a wider band. And you guys have your own fan coming, which is even better. And again, that's, you know, that's a lot of these hot end makers make their hot end specifically. The Pico guys with
Hmm.
their little Pico hot end, they did the same tests I did with their Pico that they did with all these, and exactly got the exact same measurements and exact same
Right.
room ambient temperatures. And again, it was, they use their own special little micro fan,
Hmm.
and it works.
Yeah.
So, but Greg has a good question.
Okay.
He says one more. Yeah, one more. Sorry. Why the heat sink in multiple parts? If you look, the fins look like they're separated parts. Is it true that they're separated? I didn't look that closely.
No, it's the heatsink is monolithic. It's
Okay.
just one part. Yeah.
Okay. It just
Yeah.
looks like it because it's all fancy and engraved and
Yeah.
machined. So it's all
Yeah.
just one machined aluminum piece. So that is aluminum.
It is aluminum. Yeah.
Okay.
Yeah. So still aluminum. It didn't make sense, price point for where we were aiming to do a copper heatsink.
Yeah.
Although that would be awesome.
Yeah. It'd be heavy though. I mean, maybe
It
in the
would be
future.
heavy. It would be heavy.
But in the future, you could release like an upgrade. Want a copper heatsink.
Yeah, maybe. Yeah, maybe.
So I mean,
maybe. There's definitely options. The whole,
yeah,
part of our design philosophy is we want things to be modular. We want things to fit across the board, and so, there will be, I'm sure, more versions of the Copperhead coming, and we've got more versions of the Mosquito coming as well. So we've got a lot of exciting things in the pipeline.
I'm excited for more things in the pipeline. I got things in boxes that I want to look at and stuff, but oh no, I keep forgetting my basement's really cold, so now my printer with your hot end on it just went to min temp.
Oh, that's not good.
Prusa sets their min temp to 17 degrees Celsius, and it's annoying.
Right.
It's I live in the world where my basement is 17 C, so
yeah. A lot of times we actually, all the printers we have, all the Prusas that we have in the office, we change the min temp on it because
which is cold. Weird. Marlin suggests 5 C.
Right. Yeah.
Prusa's 15 or 20. I'm like, what?
Yeah.
Why so high?
Yeah, I'm not sure why they do that.
I don't.
I'm sure they have a good reason, but
well, I know back in the day, thermistors weren't very accurate below 20 C or something like that. So they're like, well, if it's not accurate below this, maybe it. Yeah, I get it.
Yeah, maybe that's it. Yeah.
But they are accurate to 10 C. So I don't know why that's illegal.
Yeah, we've got a lab. Basically, our office is in a lab. What used to be a lab. So there's a lot of air changes, and the AC is set kind of lower because we share the unit with people that are actually doing lab work, and so we if we don't change our min temps, we hit the min temp all the time.
Yeah, I change it on my other printers because all the community firmwares all have it set to 10 because I told them they should. So
gotcha. Yeah. That's honestly that's what we do. We bump it to 10.
Yeah. So I need to do that on this one. This was running all stock, which was nice to compare. It's difficult when you're testing things. Some people complain if you run the same G code, well, you should have optimized the G code. Well, I'm just comparing what it can do side by side.
Sure.
And then if I do change a G code, well, that's unfair. You just did better settings for that one. I'm like, I can't win.
Yeah. So, I think you probably, if you want to do the best test, you just do both.
Yeah.
It'd be a lot more time though.
And I normally do. It just when you present it, they're like, "Why don't you have this?" I'm like, "Well, that's next." Give me 5.
Yeah.
It takes 12 hours to print some things.
Right.
I'm tired of test cubes. I have a box of test cubes. I'm really tired of test cubes. So
test cubes get old. We have this huge. You guys have probably seen the Voronoi torso model on Thingiverse, right? So that one's famous. It's a great test print. So we have boxes of those and they're all written on the bottom okay, this is with a 0.2 nozzle, this is with 0.8, this is retraction here, all these different settings. Yeah, see, like that. Anyway, but it's you don't want a bunch of those laying around when the kids come tour the office, so they're all in boxes up on a shelf somewhere. So
I'm the same way. There's at least a few boxes of cubes, and I started printing Q octos instead because I liked having the circles really helped. I feel that circles are better than squares because not a lot of things that people print are just pure rectangles.
Sure.
So I wanted to have the contrast. Here's something that takes an hour to print, Q octo. Here's a cube that takes an hour to print. And I gave so many Q octos away to kids, and I'm just I don't need these. And they're like, "What's the writing on the bottom?" Don't worry about it. I don't know what 0.2 means at 60 millimeters per second. I don't know what that is. That's nothing. Oh man. So, but you guys got funded. So
we did. We got funded last night.
This is literally Christmas, right?
Yeah, it's great. So. We were a little worried, with the time of year that we launched.
Christmas is tough.
Christmas and people probably aren't looking at Kickstarter during the holidays while they're traveling.
They do that.
The only reason I'm looking at it is because I've got it. Right.
Yeah. I kickstart a lot of board games, so it tends to be springtime. I'll kickstart some board games. Then by my birthday, they show up. It's
sweet. That's good timing. Actually,
it's usually 6 to 8 months for
for
board game Kickstarter. So
sure, that's pretty cool.
It's not bad. I like it. Because they'll put your name in the book, and you'll be like, "Oh man, that's me."
Oh, that's awesome. So that's good.
Yeah, it's not bad. Really it's a nice reward.
Sure. Yeah.
You can engrave all our names on the Copperhead in really fine electron microscope.
That would be very difficult, but I don't think our laser engraver will go down that
man.
tiny.
Well, this is to make bigger hot ends.
Oh, there we go. What do you just make a giant one?
Yeah,
And
one
then
giant
engrave everything's-
copperhead and start
Yeah.
engraving. Yeah, I'm okay with that. All right. So the audience, you guys got any questions? You guys, this guy, the 3D printing Belgian says he never uses cubes. And again, I try not to anymore. I mean, I do when I check like ringing or whatever, but it's usually a cube first to make sure nothing sets on fire after I do something. 'Cause I haven't had that happen. Oh, okay. I won't lie. I did grab a screwdriver and try to move a, this was the best. I had the silicon sock going on a printer and I was like, it needs to get under this wire. And
Right.
I used a screwdriver and I touched I was on and I
Right.
touched the thermistor wires or the heater cartridge wires. And I got a big spark and some
Shorted 'em.
fires and it was fun. And then the heater cartridge didn't work anymore. So
Oh, that's shocking.
yeah. So, which was hard because on those I had to take the whole thing off. On the slice ones, if I broke it, I just
Right.
used the connector and be like, I
Right.
replace just part of
There
it.
you go. And with Copperhead, you can just unscrew one bolt, drop the whole.
You know what's
drop the
funny?
whole
I had to do that because Max sent me this extruder to test with
Mhm.
the design, but unfortunately, the block he didn't set it like in the perfect height, so it's actually a little bit lower
Gotcha.
than it should be.
Okay.
So I couldn't fit everything underneath the hood here. So I actually was like, oh crap, I can just unscrew it and twist the block 90 degrees and screw it back and then I'll fit. And I was like,
Sweet.
neat.
That's great.
Didn't
That's
have to redo everything.
Yeah. That's a nice nice little feature.
Oh,
So,
Aaron Oakes asked, here's a good question. Is there going to
Okay.
be silicone socks for the Copperhead Mosquito?
So that's a great question. So if you guys were at IRF, we had silicone sock prototypes. It was like a pre-production run that we'd done for the Mosquito. And we were not super happy with how they turned out. And see, there you got one. So we weren't super happy with how they turned out. So we were going back and forth with the vendor. We don't do that sort of thing in house. Like,
Yeah.
it's way too expensive to try and bring that in house. So we were sort of just looking at the numbers and what it would take to get it to where we wanted it. And we just weren't happy with what the outcome was. So we basically canned that initiative and shifted gears because we don't want to come out with something that we're not happy with,
Yeah.
And so we're
Well, if it
looking
makes you
at.
feel any better, I really like this. So,
Okay, I'm glad you like it. So we're working on other options for that would do the same thing as a sock would do, but hopefully a little bit better than a sock. So yeah, we'll have, if it works for the Mosquito, which hopefully we'll be able to. We should be able to finish up testing in like January, February on some of the options that we're looking at. We're hoping to have that available for the Mosquito like February or March timeframe. And if it works for the Mosquito, we'll launch it for the Copperhead as well.
So I have a limited time item. This is awesome.
Yes, that is, you have, I don't know, maybe one of 100 or something.
Yes.
There's very, very few of those around in the wild.
And one's on my printer. And again, I didn't notice any temperature, like my PID tune didn't change drastically when I installed it. And again, PID tunes change micro anyway every time you run it.
Sure.
So I can't tell. Like there's no physical way for me to tell. I've even looked on Repetier server, which shows me the graph. I'm like, they both tuned great. So I can't tell if there's, but it does keep it a little cleaner because sometimes I'll get little pops and if you mess up, it'll keep your block cleaner. So
which is great. That's really, one of the complaints that we've, I guess there's two reasons people use use the socks, right? And one is to keep it clean, keep the block clean.
Yep.
And two is to, if you get like min temp errors or like the block is cooling down too much.
Yep.
So the answer for the block cooling down too much is it's actually that's improperly directed part cooling fans.
Yeah,
like really,
which is very common.
It's very, very common. So really, to get optimal printing, especially bridging performance, you don't want that air sort of blowing around all over the place. You want it pointed at the tip of your nozzle,
Yeah.
where the filament's coming out. So
And downward, not
downward,
this way.
right? Exactly, and downward.
Because this
So
way
if
means there's turbulence going up and left.
Precisely.
Yeah.
So if you're getting, errors where your block is cooling down, I would highly suggest fix your part cooling. That's a sock is a temporary fix, but if you want better prints, fix the direction of your part cooling ducts. If so, that's that issue,
Yeah.
right? In terms of keeping the block clean, a sock is a phenomenal way to do that.
Yep.
And we hope to be able to, again, provide a solution, but it's not going to be like what everybody else is doing.
So if you want a really good idea for a new product in the future, because I can't make it, I really wanted to make this like Hydra cooling thing where it's a specialized centrifugal fan where it's, kind of like a 50-50, like the blower here.
Right.
But on the end is bendy stems.
Sure.
And you can, maybe 4 or 2 stems, and you can aim them exactly where you want.
Yeah.
I have no idea how to make that because
like liquid cooling on a CNC.
Yeah.
Yeah.
So, you'd blow the air exactly where you want it, and you can mount the fan anywhere you really want it on your extruder design, because you would just get longer or shorter tubes. I mean, you'd lose some static pressure, but in the long run, you can aim exactly where you want. And that's the thing with like the Prusa cooler and stuff. There's a lot of forward blow, and that forward blow is literally right into the block.
Right.
So I don't understand the design. And I've seen a lot of designs like it. Like if you look at a lot of the especially Chinese printers, it's literally just blowing air directly into the block. But they usually the Chinese brands, they'll cover the block in that heat resistant fabric tape.
The tape.
And some Kapton, and you're good because it's thermally insulated, but you're still blowing cold air into a hot block, warming the air before it hits the material you're trying to cool.
Right.
So I still find it very ineffective. That's why I really wanted this really cool bendy positional fan where I can just like, okay, here I mount this fan, and I'm going to move these little octopus arms, and that's going to blow exactly where I want it. Rear cooling sucks. I just move this a little bit more over there.
Exactly.
Boom. So that's next.
I think I can't remember. Did we send you cooling tubes?
Yeah, you sent me the tubes. I just have nothing to mount it to.
Yeah. So we've got these little
I can't design for
tubes.
crap.
Yeah, we've got these little stainless tubes. So yeah, we got to find a good way to mount them that is
bendy arms,
modular enough to work for multiple people. Bendy arms. All right. If we can find a way to do octopus arms, we'll make it happen.
I'm telling you, there's got to. I mean, I know they make like
there's got to be a way to do it.
What's that stuff called? The electrical wire that's in the bendy tube. You need something to actually lock in place. Like you bend it and it's there.
Right. It's gotta stay put, because otherwise, once your print heats up, you might end up with like saggy arms.
Yeah.
Which should not be good.
No. Yeah. So Greg just mentioned the Bird Air, which unfortunately from every test I've seen of the Bird Air, it doesn't blow effectively, because trying to do those little itty bitty holes is just restricting. I did a project. So I'm a photographer. I did a rain shoot for a company, and I built this thing out of plastic tubing, PVC piping, and a bunch of holes drilled into it. You lose a ton of water pressure, which is the same thing when you have air pressure. When you have a big tube with a ton of little tiny holes everywhere, unless the holes are extremely small, but then the fan isn't powerful enough to force it through the really small holes. Again, air, people like to say airflow is like water flow. It is to a degree, but water has mass. Air has very little mass. So when you're trying to force water through things, when it's accelerating, you get some force behind it. When you have air moving, you get inertia. When you have air, you get inertia, but once air hits something, it's like, I have very little mass because I'm just air. So the Bird Air isn't very effective. I've seen a lot of people made a Prusa and they put it on. I'm like, my cooling got worse. I'm like, because it's blowing a little bit of air exactly where you want it. You want a lot of air exactly where you want it, plus down more. You want to keep cooling all the layers below as well. So see if anyone asked anything good. Oh, someone backed the Copperhead.
Woo,
number 295.
That's awesome.
Oh, someone mentioned the White Knight, and someone said the hot end I built him hasn't clogged since. I'm like, yes,
Awesome.
it's a good time. Bending the tube is a pain in the ass. Yes, for the bird. Bending tubes in general is a pain unless it's got
That's
joints.
true. That's true.
Unless you get, I mean, I remember I installed electrical conduit around in my old studio, and I had to do, and it was a 4,000 square foot studio, and I did it all with exposed conduit. And I am not a professional tube bender. That stuff's hard, man. But it'd be really cool to maybe make tubes that you can bend, but you make a little jig, just like they do for tube bending jigs, and just here you can make your angle like this.
One.
Yeah,
a mini tube bending jig.
Yeah,
that'd be fun.
Yeah, and then you mount. I don't know. These are just crazy ideas.
Yeah.
I mean, no, man. What? A White Knight, the Knack 3 Designs guy does the White Knight bed printer. He's like, do you have any of those? Are there any of those socks left? Yeah, there's one right here, and one over there.
I might have one in the office. I'm not sure. I'll check. Send me a message.
I really liked it. I mean, I thought it was going to be a hit.
The problem is, well, a couple things. So it's a platinum cured silicone, so it runs up to 280 instead of like 210.
Yeah.
But it got a little bit too droopy.
Really?
Yeah, and so we just didn't like that.
Yeah, the E3D ones. Oh my gosh! Like, if you print PETG too much, like I do, I have to change a sock at least every couple months. I'm changing a sock because the back end will just droop out and it stays permanently like that afterwards.
Yeah. So we didn't want that, and so anyway, we figured out, if we were going to do it in the U.S., which we really wanted to do, then we would have to sell an ungodly number of socks to even break even.
Yeah.
And because the molds are just so expensive to make the molds. So
it's 10 grand usually just to make a cheap aluminum mold that's not very detailed. I mean, a lot of people, I remember when people were knocking Prusa, like, why don't they do injection molded parts? You do understand with the number of revisions they do on parts,
they wouldn't be able to do that.
It's literally 10 grand, and you can't do certain things with injection molding that you can do with a 3D printed part.
Right.
Internal little stress points, you can't do that. Like that, you just print a thing with a certain amount of holes in certain directions, and it should work, but it's not easy.
Yeah.
And it's expensive. It's really, my buddy's a toy maker, and he tried to do he does vinyl figures now, and he works with a Chinese company, but every time he does it, he's got to sell 5,000 action figures to, make his profit plus pay back he's got a really cheap place that does it. They do, they're not aluminum molds. They're reusable, something molds. They're only good for 800 units, and then you have to toss them.
Right.
And a lot of people don't understand that when you make an aluminum mold, they're not good for lifetime.
No,
they're only good until certain 10,000 products or 20, and then you got to retool it or make another one, which retooling costs money, and retooling also can change the dimensions, and can't have that.
Yeah, it's injection molding is hard. And it's not a business that we've been in before, so there was some sticker shock involved with figuring out how much it was going to cost us to make these molds in the U.S. Yeah, so
a little bit.
A little bit, yeah. It was it was a lot of money. It was a whole lot of money. So unless everybody out there wants to buy 1,000 socks each, then we'll go make some molds.
Well, what you could do is release the CAD design for a maybe 3D printed mold thing, and people can make their own and just.
Yeah, there are actually a few decent ones out there.
Yeah, I saw that
on Thingiverse that work perfectly fine if you're willing to make your own mold or make your own silicone sock.
Yeah.
So.
Just wrap it in that tape fuzzy thing that everyone else uses. This stuff's just nasty. Someone just said, will it use the same nozzles as the Mosquito? Yes, it'll use, because you can adjust the height of the heat break in the block. So I have a V6 nozzle on there. I can even use that weird double thing. You just are just moving the block up or down depending on how far you screw it up. So yeah, you can use even crappy short nozzles that shouldn't go in there, but you may affect its ability to cool correctly because you're now moving the block closer to the transition zone. But you can do
But you
it.
can do it.
Yep.
Yeah, you can do it. Yeah, so as
here's
long
a
as it's
question.
an M6 thread.
Oh man, someone just asked a tough question. Nozzle X versus vanadium. I have both. Nozzle X had serious extrusion issues for me that went away when it went back to brass. When you work with steel nozzles, even vanadium, I have tungsten nozzles. I have a tungsten carbide nozzle I've tested. I've got sapphire nozzles and ruby nozzles. The ruby and sapphire nozzles all have the same issue, which is bad flow. So, but they're brass and they conduct better, so you don't have to adjust temp. So you've got that. Move that aside. You've got vanadium nozzles and Nozzle X, and now Micro Swiss has a variant that's the same tool hardened high speed steel with, anti-filament coating and whatever. It's still hardened steel, so you still have thermal issues. So because your fan is blowing on that nozzle, typically it's cooling quicker. It also doesn't have the same heat capacity, so 5 to 10 C higher, maybe even more, but I've never had to put my vanadium any higher than 10 C on some materials. Sometimes it's 5. So like PLA, sometimes it's 10 because the fan just blows directly at the nozzle. But if it's extrusion issue, it could be the cooling is too high and it's cooling that nozzle too quickly. So up the temp even higher. Or, it just could have been an off nozzle because you can get off nozzles from any company. So just look at it. If you're having a ton of issues, hit up the manufacturer and see what they say, because they might have a recommendation. But for me, it's always heat. If I have issues with a hardened steel style nozzle, it's always a heat issue. It's not enough, not printing hot enough to get the material to come out as fluid as it should. But if you're printing a crap ton of carbon fiber and glow, definitely have one of these fancy new nozzles that everyone has, because they're really good. Someone posted a picture the other day of like half a kilogram of glow they printed on a brass nozzle, and it went from like 0.4 to a 1 millimeter nozzle in one print. So there's a reason why we have these, and
right.
The future is still like who can make a really good tungsten carbide nozzle. But after talking to an actual tungsten company and talking to a bunch of people, it's just there is a tungsten carbide nozzle on the market, but they're all really poorly manufactured. I mean, I've put them under microscopes that cost $100,000, and they're not well manufactured, because you don't just drill into tungsten carbide. You hit that thing with lasers and bore it out, and you have to cast it first, and it's not fun. It's not fun, and it'd be really expensive. I mean, you guys can try it. But I'm guessing you've probably looked at it already and you're like, wow, that's a really expensive nozzle.
Yeah, we've looked at it. We actually looked at it before we came out with vanadium. And that was before anybody else was doing it. The manufacturing process is very difficult. So we figured out how we could do it, but it wasn't going to be cost effective for the price point we were looking at.
Yeah, because I mean, even the dies is like a hybrid. It's got the tip is just tungsten carbide,
right,
and the rest is something else, brass or whatever, and coated. And the machining on it is despicable. I mean, it shouldn't be in the market for as poor. And it works. I mean, it still prints. I mean, I won't say don't buy it. It will print, and it'll probably be the only nozzle you'll ever need. But for the amount of money you're spending, it's looks like someone took an awl and just started hammering into a piece of metal until they made a hole shape. But yeah, I talked to Midwest Tungsten, who makes tungsten nozzles. I talked to them like, can you
Which
make
is different than tungsten carbide?
Yeah, it is. But I asked them if they could do it in tungsten carbide, and they go, "We have the technology." Right. We were talking about $150 nozzle.
Yeah,
I was like, but I only have to buy one. But then I realized like how many people are like, okay, I'm already tired of buying $100 ruby. Like that's already pushing people to the limits. Like, but people have an expectation of how much they want to spend on something, and $150 for a nozzle is just like, it's so tiny, and they said they could probably do it for one brand and one brand only. Because again, when you make nozzles, you want to cover more than one setup, but darn those MK8 nozzles and raised nozzles, and
there's a bunch of different varieties. I don't know, if we find a better way to manufacture it, we'll do it. But in the in the meantime, it just doesn't make sense.
Well, if you get bored, hit up Kyle at Midwest Tungsten. He's
Okay.
the dude is super tungsten man. Like you
Okay.
ask him tungsten questions,
He
and they
knows
have
it.
the machining to do it, so they can make you
Right.
one and can be like,
Yeah.
"This is neat."
Yeah.
Because they make an actual V6 replacement. Same, actually, it looks almost identical to your vanadium because it's a 6mm.
Mm-hmm.
6mm versus 7mm. Yep.
X.
Yep. Hex.
Yes.
Oh yeah, and then White Knight's like, no, you need a 4.4, a 0.6, a 0.8, a 1mm, and a 1.2 for each. Yeah, no, that's so
it ends up being a lot of product codes.
Yeah, and then
You
a lot
gotta
of
have a
money
different
because you have to have
drill.
stock.
You gotta have a different drill for each, or if you're doing tungsten carbide, we wouldn't do a tungsten. We would want to do a tungsten carbide because that takes care of your conduction issue, like that. Whoever asked the question about the nozzle cooling.
Yep.
The tungsten carbide would take care of that. Tungsten does not take care of that.
No.
So
Tungsten is like stainless steel.
Right. Yep.
It's not a good conductor, but it's stronger than stainless steel in abrasion resistance. So you get a bonus.
Depends on the alloy.
Yeah. Let's see. Is a nozzle made of tool steel? Yeah. So that's what vanadium uses, or Slice uses for the vanadium nozzle. It's high speed tool steel. So basically, the tool that cuts steel is what they made the nozzle out of.
Right.
So it's extremely hard, and then they coat it with multiple coatings. So you've got a coating that's anti, just with the first. It's like a nickel coating is the first one.
So we have a nickel coating, and then there's a tungsten disulfide. So there's actually tungsten involved.
Yeah.
But the idea is to try and reduce plastic adherence to the nozzle. And we're always experimenting with coatings, so there will be we like coatings. There's a lot of different coatings that we're messing with. So,
and I actually bought I don't know if you ever looked at P3D. They make an aluminum nozzle and they coat it. I actually really like that Apollo nozzle.
I haven't tried it.
I've never tested it thermally. Apparently it's supposed to be better than brass for some reason. I think aluminum has a higher thermal capacity. I forget what it was. Either it's better. I know it's better at transferring heat directly. So when it's hot, it's hot. Like great. Copper has a large thermal capacity. So when it's hot, it stays hot because it just keeps that heat trapped in, which is great for nozzles.
Thermal mass.
Yeah. But aluminum is weird, but apparently it works good for nozzles. I get great prints out of it, but
interesting. We'll have to try out the aluminum nozzle.
Will this fit a Hemera? I think they have a special heat break for the Hemera, so I don't think you guys have that on the pipeline.
No, not for the Kickstarter. When we were planning the Kickstarter, Hemera was not out yet, so we did not know about that heat break. Now that the Kickstarter's been funded, we do want to have a range of. We'll basically do a similar thing. If there are other printers that are in high demand or other heat breaks that are in high demand, we'll probably do some sort of pre-order or something for other variants. So
nice. Yeah, apparently it has a 4mm thread heat break. So yeah, that won't work.
Yeah, and it's also got a sort of like a shoulder.
Yeah.
That prevents it from threading in too far. So. It's
These
totally
all make
different
sense.
Construction.
So how about a complete extruder from Slice?
Sure. So we've got a really good partnership with Bondtech.
Yes, you do.
And we really like working with Bondtech. They make a great product, and we have a lot of co-developed products with them in the pipeline that you guys should be excited about. But there are no plans at this time to do a complete extruder from Slice. So, but look out for co-developed products from Slice and Bondtech.
Because I definitely have a BMG Mosquito behind me. Magnum, actually. That thing's printing pretty ridiculous. It's pretty funny, when you print. I brought that crazy diamond filament that you can print up to 500 millimeters per second, which you can't do on a Prusa because it can't heat that fast anyway. But it was fun printing it. I think I had it live and I was printing at 250 millimeters per second on this actual printer because I had the Magnum on this originally, just by itself, Magnum in your R5 extruder. And I was just like, bzzz. I was like, that's neat.
That's impressive. Quality was actually pretty.
Bed slingers are not meant for that kind of speed. Certain things happen and certain parts are flying off at those
Right.
speeds. Well, what about a slice printer?
That's a good question. We want to make sure we're really good at one thing. There's this book that sort of guides my business philosophy, and it's written by a guy named Jim Collins. It's called Good to Great. Phenomenal book for anybody that's interested in business. But one of the things he talks about is this flywheel concept. And the idea is that if you it's really hard to get a flywheel going, it requires a lot of energy, and a business is the same way. Like, it requires a lot of long sleepless nights, where working weekends and working while you're on vacation and all that to get stuff moving and off the ground. And the idea is once you get a flywheel going, it maintains a lot of momentum, and you can pull energy out of the flywheel to drive something else without stopping the flywheel. Right?
Yeah.
So that's the way a business works. So if you've got a lot of momentum on a flywheel, you can just jumpstart another flywheel with it, right?
Yeah.
But we won't be branching out to other aspects of business until we have our main flywheel running, because otherwise we will die. And I would like to continue to live the dream and not bury it. So
you're the hot ends guys.
So we're the hot ends. We're the hot ends guys for the foreseeable future.
Nice. And nozzles.
Yeah.
So anything hot end.
Anything hot end related, we'll do that.
Hot ends. Yeah. I'm okay with this. And even White Knight over here, he's like, "Hey, stop trying to spread them thin." I'm not trying to. I'm just trying to pry any secrets out of them, which doesn't work very well because they won't say it anyway. But it's an amusing question to ask when you have.
Yeah, it's a good question. It is a good question.
Who would have thought Prusa was going to make a resin printer? I mean, again, it's
right.
You got to ask.
Right. You won't know. Flywheel, right? So they're selling thousands of printers a month. They got 400 something employees. They have their primary flywheel going. That's when you look at, okay, what else can we do?
Yep. So someone asked a good question. Bob is like, "Hey, if I have a mosquito, why do I want the copperhead? I thought I had the Prima hot end." If you have the mosquito, you don't need a copperhead.
Yeah.
So thermally, the mosquito is still better. It's not a huge, from what I've seen, it's not a huge difference, but it's enough to where, the mosquito has the titanium. It has the, not one-handed nozzle changes that are cold. The copperhead has to give a little bit in order to be financially, within that price point of under $100. Mm-hmm. So the copperhead is your best under $100 hot end thermally. Your mosquito is your best hot end with all the bells and whistles, but it's above $100. So they're trying to branch out to the market that is like $120. I don't really feel like spending that on something. So the copperhead is just for that, for the people who are like, I don't have $100, but I would love to upgrade what I have to something better.
So that's exactly it. And the mosquito isn't. We're also using stainless on the mosquito, so it's not titanium there. Again because the mosquito uses the same bimetallic heat break technology as the copperhead does, so same materials there. But the heat break, because it's not structural, it can be much thinner, so we're getting, again, even less heat up the filament path. You get basically in a 1 millimeter span, you get about 160 degree change in temperature, 160 degree delta from the hot section to the cold section. So it's very, very efficient, and the mosquito is going to remain the premium hot end offering. So if you have a mosquito, no need to get a copperhead unless you have, say you have like, your Railcore or something. You've got a higher end printer and you're trying to do max throughput, get your mosquito. If you've got, a lower end printer that, you just want to get it printing reliably, get the copperhead.
Yeah.
So that's sort of, we had a lot of feedback from the rep shows from Murph and IRF where people said, "Hey, I love the Mosquito. It's fantastic, but I just can't afford it." And so we wanted to take some of that tech and move it a little down market.
Yeah, and you're also, for the lowest price point, you just upgrade your already existing hot end.
Right.
So you just keep the heat sink and pop in a new heat break and new block. So the Copperhead's a solution for a broader audience. Where the Mosquito is for those people, either they're printing super high-end materials and really need the most efficient and the most throughput. So basically, like again, you said the Railcore. If you have if you have a $2,000 printer, you should probably put a really nice hot end on here. If you have a $300 Ender, 3 Pro or 5, whatever it is, you don't need a Mosquito. It's definitely an option, but you just need, if you want an all metal heat break, instead of using the PTF throughput, you just go, hey, look, here's my new heat sink, or if you get the whole kit, but you can just take the heat break and stick it in there, and boom, you've got a whole new hot end. So that's more thermally efficient and sexier looking because you'd have a whole new block.
Yeah.
So
and it's got a sweet little slice logo on there.
It does.
An orange slice.
I'm okay with that.
Yeah.
Let's see if anyone asked anything else. Oh yeah. So White Knight is Carl. So Carl, I apologize. I'm horrible with names. So, as a wedding photographer, I memorize my clients' names. Well, I know their names, but before a wedding, so I don't call them the wrong couple because like the next day is another wedding. I just sit there the day before. I'm like, all right, it's Jen and Steve. Jen and Steve. I show up. Hey, Jen. Hey, Steve. I've made. Oh man, I can't. A week later, I don't know anybody. So, like I don't know who 3D Gustner is. I know his last name's Gustner. I think I know his first name. I know I've heard it. I know Greg's name because it says Greg. Oh man! All right,
Carl sent me an email. So
yeah,
hey,
Carl sent him an yeah, about this. Yeah, I won't give that away because I don't know why I love socks, and my printers don't print high enough to melt this thing. So I don't have one of those fancy 400-degree printers. I would like one, but I don't have it. I don't have it at all. So, but yeah, I think we kind of covered everything. Your Kickstarter was successful. You explained the bimetallic stuff. You explained some of the tech. You explained why and where and what, and Florida fruit fights and
fruit fights.
We all know Jane and Steve. Who said it's my real name? Oh, Don, the German 3D printing nerd is Don. See, that's the thing is, and I will forget that, and I apologize. This is Dan. And I'm Chris, and there's another Chris, but he's from Slice, but he's not me.
Right. Yeah, different Chris.
He's better at engineering. Yeah, no beard. Actually, considering so like, someone actually just upped their pledge from the lower pledge to the higher pledge with the heat sink. So
awesome, thank you.
Would the Copperhead be preferred over the V6? It depends. So again, we're not saying the V6 is a bad hot end. I don't want anyone to get this. We're not knocking anyone's technology, but if you're having issues with, cooling, clogging, whatever, this is a great fix for that. It's not a Band-Aid. We're improving the thermals. They are improving the thermals of the hot end, which means you'll have less to no more clogging because it's thermally more efficient. The E3D V6 is not a bad hot end, but there's a reason why when you buy it, it comes with that little clip-on thing with the fan. It's meant for that fan. They designed it specifically for a specific amount of air to go through it. With a more efficient hot end, you can use poor cooling and still get really good results and not have the clogging issues. You should still use the better cooling that's available to you, but now you can use that worse cooling. You can actually use a Noctua fan and not have jams as often if you have a warm room or whatever. So we're solving an issue by using better materials. We're not saying that thing's bad. I don't think anyone's saying anything's bad or you should go out and replace it. But if you're having issues or you want to try something new and cool, hell yeah, you should jump on that Kickstarter and get something. So I definitely don't want to knock anybody's stuff. I mean, my tests were just this. And Slice isn't making hot ends to say, screw everyone else.
No,
we make the best hot end.
We're friends with the E3D guys. We're friends with Dyes. Like, we get beers with them every time we see them at a show. Like they're really great people. They're smart people. And we're filling different areas of the market, E3D sort of doing the mass production thing, and we're doing the sort of more specific applications. So.
Yeah, it's definitely a market that hasn't been tapped. I mean, there's plenty of hot ends on the market. I think the only thing I can honestly say is the Creality hot end pretty much sucks. But it works. I mean, you still get good prints out of it. Again, no matter how poorly inefficient it is and how it's screwed into a backplate and air is just blowing into this thing with a backplate on it, and it somehow works. And that's because of the PTFE liner. It works, but it's not. It's not a very good hot end.
Not ideal. Certainly not ideal. All right. Well, I'm going to have to hop off. My headset's about to die, and I've been streaming this whole thing through my phone as a hotspot. So
nice. You stole the family's Wi-Fi, bro.
Well, I didn't have time to get on their Wi-Fi.
So, oh, man. Yeah. Well, Dan, appreciate it coming on here. I think we've educated a bunch of people.
Yeah, thanks for having me on, Chris.
No problem, man. And the hot end works great. Like I've been able to do one test print on it, and there is a noticeable difference in print quality. The thermals are definitely been tested, third party. No one's paying me to say that this thing is better, and someone else repeated these tests and they're also getting the same value as I am. So it's a really good hot end, and it's successful. So we don't have to force anyone to do it, but you should all back this Kickstarter.
Yes, please do that.
Yeah. I backed it before I got to test it. So, but yeah, I mean, we really appreciate you guys coming on, and hopefully do future streams. Maybe when the Copperhead launches and it's out and the world sees it, we can do another stream and just talk about cool stuff, or talk about the vanadium. I'd love to talk nozzles. I love nozzles. Yeah, that's one of my.
You talk nozzles for sure.
Hell yeah. So sweet. You enjoy family time. I'm going to go watch, what is it? 12:13. Oh, perfect. We did an hour and 15 minutes. That's not bad.
All right.
We're all going to watch football. All the Europeans go watch your football too, because you have football.
Yeah.
with a round, we have egg hand ball. You have actual round soccer football.
Yeah. Soccer.
Yeah. So good night, Dan. Say whatever you want to say, then run away.
All right. Thanks everybody for tuning in. Appreciate you having me, and Happy New Year. Merry Christmas. Happy Hanukkah, whatever holiday you celebrate, Festivus. Hope you enjoy it. So yeah, there you go. All right. See y'all later. Good
night. I guess good afternoon. All right. That was Dan from, let me go my banners here. Banners, sliceengineering.com. Man, anyone got any more questions before I run away? Because I'm going to run away and watch football. Oh, yeah. So the orange sleeve, wirecare.com. Wirecare.com. I'll make a new banner. Wirecare.com. Add banner. Let me make sure that's actually the name of the website. Again, I have a memory of a goldfish. Yep, it is wirecare.com. And they have colors and shapes, and they even make some that are flame resistant and flame retardant, and yeah, all those things. Yeah, go every football team. None of my Chicago team is not going to the playoffs. I'm now a Ravens fan officially for the rest of the year. Yeah, Bob. So about 5 to 10 C higher for a vanadium. So any of those hardened steel nozzles is 5 to 10 C. Some people say you don't, but you should definitely 5 to 10 C higher. If you're having extrusion issues, especially, it's good to take a look. It will run on a CR10S Pro. Yes. And Happy New Year to you, 3D Gusner, which I don't know your name. So I'm going to call you Steve for now, because apparently everyone is Jane and Steve in the chat. I do apologize. I'm horrible with names. It's goldfish memory, man. Production. I think it's on there. Let me check Kickstarter.com. It shouldn't be long. They've got physical units in hand. Search for the word Copperhead. Copperhead 100. Ooh, 100 and wow, they went up another like $5,000 since the stream started. Let's see here. Do they have the when does it say it ships? Should say the estimated delivery is March 2020 for everyone. So production starts immediately because they already have all the manufacturers that they need already in line, ready to go. So they should be said they're shipping March 2020, and they are really good on their timeline. So yeah, the brass nozzle will work. I mean, it's definitely more efficient. So when you put those hardened steel nozzles on there, you got to compensate because your PLA typically is very easy to print. So when you print PLA, you don't have to change the temperature because its print range is like 180 C to 215, 220 C is typically the print range of PLA. Now, when you put PETG in, its temperature range of effectiveness is typically higher. So you want 230, 235, 240. That's typically its optimal print temperature for most brands of PETG. But then you add the hardened steel nozzle, which drops at 5 to 10 C. You may, if you're printing at 230, 235, you may be below its optimal print temp. So it'll under extrude. The layers won't bond correctly. You'll get a very matte finish. If you have a matte finish with PETG and it's not matte PETG, typically that's means you're either printing too quickly. Again, I don't recommend printing over 60 millimeters per second with PETG. On infill, you can probably push it to 100. If you're printing hotter, like I tend to print at 240, minimum 235, 240, 245 for PETG. Most brands I've tested are in that range. But definitely increase that. The naked white night guy. Yeah, Carl, man. And it was funny. We had a stream and I called you Carl the entire time. But that fish, the goldfish memory of mine. So the Mosquito isn't meant to, it's not a direct one-to-one replacement. You'd make a new mount for it. So they made a bunch of different mounting options. So if it's got a groove mount on that printer, you would just get the groove mount adapter, put it on the Mosquito, boom, adjust your heights. But I've never seen this Troodon printer, Troodon, Troodon 3D printer. Yeah, so with the atomic filament PETG, 245 is pretty good. Vivendio Trondon Core X. Wow, this thing looks cool. The price is only $1,500. That actually looks really sweet. Huh. I've never seen this printer. So yeah, if you had, the Copperhead would work in there. I think they have, I don't know what hot end it uses. Let me see if they've got some descriptions. Ooh, 32-bit controller with 2660. That sounds like it uses a duet board. Filament runout, sensor power loss. It does not say what the nozzle is or the hot end is. I just said nozzle. See ya, 3D Gusner. Hey, Jake from State Farm. You just caught the end of the stream. Ooh, it's got a magnetic PI flexible bed. So the mount I'm using is the guys from Slice edited the stock R5 mount for the Prusa Mark 3S to fit the Copperhead. It doesn't fit perfectly, but it fits. So, wire care. Let's go back to the cool stuff. Kickstarter, sliceengineering.com. Okay. All right. Well, I think it's time to end the stream. How many people we got left in here? It was a pretty big stream. 75? Man, what was the max? There's no max on there. Oh, well. There's the max. We almost reached 100. 99 viewers. That's not bad for a Sunday stream. So yeah, all right. Everyone, thank you for joining in on the stream. Thanks again to the guys at Slice. So Dan, appreciate you hopping on. To everyone else that joined in, you guys, some good questions in there. And don't forget to sing a bit, Chris. No singing from Chris. So everyone go enjoy an amazing Sunday or Monday, depending on where you live. If you're in Australia, it's probably Monday. Enjoy your day, whatever day it is in the week. Go watch some football. Go eat some things. There's probably some leftover Christmas food somewhere in your fridge. Might not be any good, but it's food. And then everyone have a happy new year. I'll be back on another stream soon. I got a stream coming up for the printed solid enclosure for the Mini, and I've got some Jesse PLA. I hope to get Dave from Printed Solid on here, and we actually will watch his extrusion line live. So that's going to be sweet. So can't wait for those streams. I'll also be doing a rep box stream, and I can't think of anything else. There'll be other streams. There'll be more streams coming. So everyone stay out of trouble. Enjoy your weekend or weekday, depending on where you live in the world. And I will talk to you all in a very short time. So have a good night. Have a good day. And enjoy the football. Hope your team wins.